Okay, yeah, thank you for the nice intro and having me. It's great to be here to give this talk. Before I start, I want to basically make a remark. So a few hours ago, there was this discussion here about if you should buy or build technologies, and I had the impression that more or less everybody in the audience was clear that you should buy it and not build it, and I strongly disagree with that, and probably we have time to discuss why. I disagree for several reasons. I hope we can bounce arguments forth and back during the apéro. Probably you have spotted that the title on the slide is not the same like you have on the program, but you can trust me, so they mean exactly the same under the hood. So I'm gonna share with you some insights from a real project we have done at Tamedia, where I've been involved together with Sarah Safri and Joël Bühler from the Tamedia data team. I didn't prepare an agenda for you, sorry, but I can tell you, I promise you, I will not talk about AI world domination or fairy tales like that. So basically, I want to talk about statistical methods helping marketeers to define optimal strategy for their campaigns using different marketing channels. So the overall goal of the project was to build a kind of an oracle you can query or you can ask, which gives basically an advice to a marketeer how to spend the budget over different marketing channels to optimize predefined KPIs. Okay, that was the overall goal. And one of the reasons I disagreed with the opinion that you should more or less always buy technologies that we had a story at Tamedia, so we tried to buy basically technology to do exactly that, and we greatly failed. So we built our own machine doing this oracle. So how does this work in a very high-fly way, let's say? So if you want to basically have such an oracle, of course what you need are data. So no data, no party, that's clear. And as data, we had input data, and the input data basically are the spendings on different marketing channels from the past, like the spendings you have done for campaigns for on TV, radio, print, and so on. We included external factors like holidays, also weather could be an option or could be important, and also some signals from competitors. Then we had internal factors included. So for example, if you relaunch your website, that might have an impact on certain KPIs when you during your campaign. So you have to take care about these events, for example. And also lag effects on spending. So when you spend on a specific marketing channel, you do an investment for a campaign, then probably this spending has not an immediate impact. So you have a lag effect, and you have to take into account that for the model. So when you have this data, basically, then also you need the target, and the target in that case are the KPIs. Now the KPI can be just an entering visit, or can be a conversion, like an ad reply, or just revenue. Okay. So the first step is to get your data right, and I can tell you that this is the most difficult step in the whole chain I will present you. So to get the data right, or even to get the data at all, and enough data, probably is the most difficult one when you want to do something like that. It has been mentioned before several times, but I mention it again because it's really important. Then the second part is a modeling part. So basically what we do there is we have now the input data, so the spendings, external, internal factors, influencing the KPIs you want to maximize. So what we do in the first step is basically, if you want, we fit basically the input data to the output data. So you have the input data and you have the corresponding KPI you want to maximize with your campaigns. And we train a model basically that then is able from the input to basically predict the output. As I mentioned, the output are the KPIs. So yeah, there are nitty-gritty details like you have to do several train tests, data splits. You have to be very, let's say, serious when you evaluate different model types and so on. The output of the second step then are the weights of your attributes, which means that it tells you, so this weights tells you what is the influence from a certain attribute to the KPI. Like, what is the influence of my spendings in a TV channel to the KPI revenue, for example, okay? So this is the output of step 2. And then in step 3, what you do is you input those weights to an optimization process. And this optimization process basically gives you then the optimal mix for a specific campaign and for a specific KPI. So in this optimization process, you also input some constraints, like what is your overall budget, what is your, let's say, minimal spendings on different channels, what is your maximal spendings on different channels. So basically this oracle is built based on these 3 steps. So you get the data, you fit your input data to the KPIs, and you basically feed the weights of the attributes, so of the influence of the influence of the spending to the KPIs. You feed them to this optimization machine, which basically then outputs you an optimal mix. Okay, so that's high fly, but it's what we have done. Now, to be a bit more concrete, I want to give first some general remarks, what you have to take into account when you do something like that. So first of all, you cannot fully automatize all the steps. So you need always human intervention to control and to check the quality of what is the output from one step to another. Then our advice is start always with the simplest model you can find. Never start with something like a bunch of linear piecewise function approximating nonlinear functions locally, which is just a silly description of what a neural network does. So start really with simple things like a simple regression or something like that, and then gradually increase the complexity if you're not satisfied. Never trust the output of your model, never, ever, and try really hard to prove the model being wrong. Okay, because there are always 2 cases. So one case is your model does not work at all. So then you can be sure there are some problems, you did something wrong and so on. And the second case is it works very good, but it's the same, something is wrong, cannot be. So really try hard to disprove what the model tells you. Yeah, then you should basically be able to explain to somebody else what the model is doing. So if you, somebody mentioned it also today, we explain black box models. So if a model is a black box, you cannot explain it, else it wouldn't be a black box. So try to use simple models because you can explain them to somebody else. You can explain them to a marketing let's say, chief marketing officer, and he can understand what the model is doing. And the third is, yeah, probably, there is for sure no one-size-fits-all solution. And if somebody claims that it has it, you should be very suspicious. So, yeah. Okay, so a bit more in detail what we have done. So what I'm showing you are components of this oracle now, let's say. So the first one, of course, is this data reader, and it has been mentioned before, I think Marco Hochstrasser. So you have to be careful, you have to normalize your data. The data quality has to be on a high level. And you also have to check that your data basically fulfill the assumption of the model you want to use. Okay, so they are. So that's the most important part. So if you feed crappy data in your model, you get out crappy things out of the model. It's quite simple. Then this data, basically, they go to a model configurator, and in this model configurator, you can define your model, let's say. So in the simplest case, you have a regression model, for example. But you just can't use a regression model because, for example, the regression model would output you something like negative contribution of your spendings from a specific marketing channel, which makes no sense, right? This should have a positive effect. So that means that you define, it's called priors. So knowledge you have, you basically want to give to the model, and the model to behave according to that knowledge. In that simple example would be that all the contributions of the past spending should have a positive effect on your KPIs, okay? And then basically we are calling a so-called model worker. So it initializes the model, it loads the data, and it compiles and runs the model. It generates these coefficients, which are basically the contribution of your attributes to the success of the KPI. Finally, we get some reports out of that process. So I'll show you an example afterwards, a few slides later. But do really these checks. So check the statistics, if the fit is okay, if your residuals are really, depending on what you do, normally distributed and stuff like that. Finally, we call the optimizers, and the optimizers basically outputs you an optimized channel mix. Now here, these are real data. It's not fake. You can trust me. So the different colors means different strategies or different model parameters. And then you have the channels. So, and then a chief marketing officer or whoever has to evaluate what is the most appropriate strategy to try for the next campaign. Now this is basically this is an output and an input. And what you see here, there is no clicky bunty stuff. So So basically, these kind of things help a data scientist or an expert like Joel from the team to model the things and to make the necessary checks. Now, what you see here is, on one hand, how you can define the model at the end, and the checks basically you can do. For example, on the upper panel, you see this straight line. So is the distribution of, it's a QQ plot, distribution of residuals, which means should be more or less a straight line, because the error should be normally distributed in that model and stuff like that. So in the panel down, you see the sampling from the coefficients when we fit the model. So, and the second step, again, this mix optimization is no clicky bunty. So you define basically your boundary conditions, your upper and lower bounds of your spendings, and the output will be a chart, in that case, which gives you the optimized mix for a specific campaign. So this is how things look like. Of course, you could build a nice GUI, let's say, but I explain you a bit later why we don't do that. For the moment now, we are working in that way. So, and it's a lot of consultancy at the end. So you produce this output, you go with the output to the marketer, you explain him the model, you explain him the output, and yeah, I think that's much more important than to have clicky bunty tools. Okay, so now this is from a real project. So on the left side, you see basically a marketing mix, or a channel mix, which has been proposed by a marketeer. And on the right side, you see what the machine proposed, and you can see some quite big differences in different channels. And of course, the marketeer probably says, I'm not really satisfied with what the machine produces here, so I will not exactly do what the machine proposes me, but I will just adapt to that in that direction. An honest, let's say, lift up we have observed are 10%. So I think it's not really realistic when you hear numbers like we have a lift up of, I don't know, 80% or 50%. So 10% is already pretty good. By the way, we try also to simulate the impact of the model to the next campaign, but it's very hard to entangle really the organic growth of things and basically the growth you would have due to the optimized mix. So that's quite hard to do. Good. So the learnings here are data quality and availability are key. So that's really the hardest part, to get the right data, to have it in a good quality. And then the control for realistic outcomes is important. So what I mean by that is, of course, you can create different scenarios. You can say, okay, I will change now completely my strategy and give it to the model, and the model outputs me something. But if you completely change your strategy and give it to the model, and it basically calculates the optimized mix, but this strategy has nothing to do with what you have done before, then probably the model will not work properly, because the model does not know or never see, for example, this huge deviation from what you have done in the past. So realistic outcomes, you can produce realistic outcomes when you change a bit your strategy, but not too much. Okay. Then, yeah, what I said, that not every step can be automatized in this whole chain. You always need a human intervention here. And I think what is really important is that you reduce this model complexity, because what I observe a bit is that people tend nowadays just to take the most complex model, let's say neural networks, and try to do something with that. But in my opinion, or in our opinion, it's not very useful, because you have to understand what you are doing. And yeah, I mean, you want to basically you want to use your marketing budget wisely. So if you just get an output from a very complex model and don't understand why the model produces in that way, that's probably not what you want. And yeah, the last one, don't be evil. Don't be evil. Okay, that's it from my side.